let's go ahead and review this so we can be done with this chapter and move on to prepping for a test. It says 6.4, practice, review and refresh. Display the data in a circle graph. If I was going to display this in a circle graph, I realize the percentages here have to be represented by multiply, or let's see, I'm going to put this over here. All right, so if I have 55 percent out of 100, right? I'm just going to put this work over here since I know I won't need nothing for number 2. So I got 55%, right? And that's out of 100. And I need to go ahead and multiply 100 to something to get to 360 because there's 360 degrees in a circle. I know this because a right angle has 90 degrees, which means another right angle next to it is 90 degrees, which means 2 more that would complete the circle would make 2 more 90s, and 90 times 4 is 360. So I have to multiply this to, let's see, 360 degrees, I guess 3.6, which means I'd have to multiply 5.5 by 3.6. And I'm going to do this to every one of these numbers down here. Again, multiplying the bottom by 3.6 because I know that 100 times 3.6 that's going to give me a 0, a 0, and a 6. That's going to give me a 0, a 0, and a 3. And that's 3,600. Remember, because I have that decimal here, I have to move 1 back, which means I move 1 back there, making it 360. And that means I would take 55 times 3.6. I'm going to put 3.6 on the top, 55 on the bottom, just because I know both the lines would be the same if the numbers are the same. 6 times 5 is 30, so I carry the 3. 3 times 5 is 15, plus 3 is 180. Again, because this is a 5 and this is a 5, I know I'm going to get the same numbers here. So 0, 8, and 1 again. Now when I add these up, I get a 0, I get an 8, I get a 9, and a 1. And of course, I have to move that decimal over. So that's 198. So this gives me 198 over 360. Now that I know that's 198 degrees, right? That 55% is going to be, right? So it's going to be over 180 degrees. So when we do this, the chicken one here, this chicken percent is going to be over 50%. As you can see, the chicken is over 50%. It takes up more than half of it. When I do the same thing, when I multiply 3.6 to the bottom of every one of these, I'm putting 100 of them, and then multiply them to the top, I'm going to get these percent. So the tomato, 18% is going to be represented here, right? It'll be 18 times 3.6. That'll tell us how many degrees here. The avocados will be 23 times 3.6 as well, and so will 4. You multiply to 3.6. And it'll give me what is the degrees. So when I'm saying degrees, remember this is 198 degrees. So when I'm talking about this, I'm saying that this right here, from here to here, okay, that's 198 degrees. All right, you're going to do the same thing over here for seafood. They're talking about the number of people. You're going to have to go ahead and take those things. Again, you're talking out of how many there are here. So this is going to be a little different. I'm just going to give you a heads up when we do this. Instead of putting 100 on the bottom, you're going to count all this up. So I know that 14 plus 8 is 24. 22. 22 plus 8, we're going to go down here. 22 plus 8 is 30. And then we have 17 and 13, which make 30 as well. This is 60 altogether. So with this one, you're going to have, when you do salmon, 14 out of 60. And you're going to have to multiply some number to 60 to get 360. Okay? And that would be 6, because 6 times 6 is 36, which means you'll multiply the top number by 6. Okay? And just to tell you how to do the first one here, you'll get your 360. And then when you have 14 times 6, well, no, 4 times 6, that's 24. We'll carry the 2, and that means we'll have 1 times 6 is 6, 7, 8, so this would be 84. So this is going to be 84 degrees, okay? And then you're going to do that to every one of these numbers, okay? You're going to multiply them to 6, and it'll tell you how many degrees each one of them are. All right, I'm going on to number 3 now. Number 3 says, write the percent as a decimal or the decimal as a percent. Well, this percent here to write as a decimal, I just move it over twice. It's going to be 0.432 for my decimal. So you see, they're dividing it by 100, and you get 0.432, just like I said, it's just moving the decimal over twice. On number 5, we have a repeating decimal. So when I move this back twice, it's going to be 0.5 or 0.58 for repeating, okay? 0.58 and 4 repeating. All right, let's go to number 7. Looks like number 6 was given to you here. I forgot to erase it, lucky you. Number 7 says, create an appropriate data display to represent the data. If I was going to go ahead and display this data, remember I should put everything probably in order, books read, right? I'm going to go ahead and put it as a book read stem lead. When I do this, this tells me that whenever I have a 0, that's things less than 10, so that would be 9. When I have things bigger than 10, I have the 1 in front of it, so that's 15, right? 1 and 5, then 1 and 7 for 17, 1 and 9 for 19. When I have number 2, that means it starts with 2, so it'll be 20, which we find right here. 25, which would be right here. 26 twice, which is here, and we also see it here. And then 29, which we find right here. And then we have numbers to start with 3, so 31 and 32. We can see 31 here and 32 over here. And the last one, 4 and 0, which is 40. All right, so the key 1/5 is 15 books. And where do they get? Sorry. 1/5, it says, create an appropriate data display to represent the data. We created it. So we're talking about 15 books, right? So let's go ahead and move, excuse me, on to number 9. Number 9 says test scores. If I'm looking at test scores for these, I'm thinking we're going to go ahead and take, well, could we use that same one? We could. We could take 6, right? And we could make it 62, 65, 68, and 69. Okay? For 7s, we don't have any 7s, so we would just put 7 there with nothing next to it. For 8s, we would put 80, 81, 82, 85, 87, 87, 88. As you can see, we have 80, 81, 80, looking for 82 here. Oh, 82, 85, and then there should be 2 87s. There's 1 and 2 there. And then 88, which would be right there. And then for 90, we should have 90, 91, 95, 97. So we got 90, 91, 95, 95, and 97. All right, let's look at homework. Time spent. Since we're talking about time spent here, I don't think we're going to use this here because we want it in relation to time. For this, we could choose time spent. If showing a circle graph, okay, which shows you the amount of spot time compared to 100% of the time, right? Then over here, you could also say that you have 45, right? And you're taking this over 144 because when you add all these together, it's 144. Now, what multiplied to 144 give you 360? All you have to do is take 360 and divide 144 to find out. You'll get 2.5. So then when you do that, you're going to multiply 2.5 to 45, and that's where you get your numbers. You're going to do that to each one of these, to the top and bottom, and that will give you your numerator, which represents the amount of space for your, it tells you how much percent out of 360 for your circle graph. Let's go on to number 13. Identifying the appropriate display. A survey asked 800 students to choose their favorite school, okay? School subject, excuse me. The results are shown in the table to tell whether each data display is appropriate for representing the portion of students who prefer math. All right, so if we're doing this, I'm going to say from a circle graph, you can see that the portion of students who prefer math is 22%. So it is an appropriate display, okay? When you're taking this, you're taking it out of all these numbers combined. You're going to add all these and make them your denominator, right? And then you're going to take 360, divide it by that number to find out what you multiply these top numbers, right, as your numerators. And that will tell you what percent, right? And how about B, favorite school subject? This time they give you a bar graph, okay? The bar graph shows the number of students who prefer each student subject, but it does not show each number as a percent of a whole group of 800 students surveyed. So it is not an appropriate display, okay? It's not showing really in comparison to the total amount of kids in the school. It's just kind of giving you an idea of comparison to each subject and not as a whole group of 800, all right? Number 14 is yours to do. Number 15 says, let me move this out of the way. Writing, when should you use a histogram instead of a bargram to display? Well, I would say when the data are grouped into intervals of one category rather than multiple categories. A histogram would be used instead of a bargram. An example would be a histogram is appropriate for data displays of student test scores in class. 16 is yours to do. Number 17 says, making an argument. Your friend says that the circle graph is inappropriate display for any data set. Is your friend correct? I don't think so. The circle graph is inappropriate for showing data as part of a whole, but it does not show the variability of data as a box and whiskers plot does, or how data is distributed as a stem leaf plot does. Okay, 18 is for you to do. 19 says miles bike per day. So which data display is misleading? If I looked at this data and just said, I'm going to say this is misleading, makes it seem like it's all the same amount because it's all coming up here. This one lets me know that the majority of my data is in the middle here at 5. So I'm going to say the first one is misleading, all right? And it says here, the plot on the left, which is the one I said, being uniform height, and the dots do not accurately display the difference in number of miles bike per day. 20 is for you to do. Let's go to 21. 21 says, modeling real life, the table shows the points scored in a basketball game during the season. All right. Says create a data display that shows the distribution of the data. Well, we know that we're going to go ahead and use a stem leaf. After we're doing this, we see over here, it says find the probability that a randomly selected game from the table had more than 43 points. And you'd say 2/3. There is 10 data values on the stem, right? Okay. And then it says, let's see, 10 data values on the stem. Okay. So we're talking 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's do that again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Looks to me like there was 11, but there are 10 data values on the stem and leaf plot that indicate more than 43 points scored and 15 data scored more than 43 points scored, I think it means out of 15 data values. Okay. This is 15 data values here. And they were talking about, the table shows the points scored in basketball during one season. Oh, find the probability the randomly selected scores more than 43. Okay, over here. Let's look at this again. So more than 43, right, would be these two. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That makes more sense. All right. So it says the probability that team scored more than 43 points in a randomly selected team is 10 out of 15, or 2/3, which is 66.6%. 22 is for you to do. Looks like we're doing 23 here. It says structure with the help of a computer. Mathematicians have computed and analyzed trillions of digits of the irrational number pi. One of these things they analyze is the frequency of each of the numbers 0 through 9. The table shows the frequency of each number in the first 100,000 digits of pi. Okay. Display the data in a bar graph and circle graph. So when we do this, I got my bar graph and circle graph showing this. Now it says which data display is more appropriate. I think for this, we're going to have to say because the frequencies are very close, the circle graph does not compare the data well as the bar graph. The bar graph is a more appropriate data display because it shows the sum of our digits occurs slightly more than others. You can tell that by these bars going just a little bit more than the other. This was really hard to tell. Describe the distribution. Well, it says each digit occurs about 10% of the time. All right, that's it. Looks like the rest of the year is good luck, and I'll see you for grading